evening, everyone. My name is Don Parkinson, and I'm a consultation specialist with S&C Lavalin. Today, we are continuing our series of live stream topics as our project moves through consultation round 2 of the environmental assessment phase. The topics we are covering parallel our project activities, so we hope these will help our viewers and listeners better understand the project and provide input along the way. So let's get started. Today, we're going to talk about the evaluation of alternatives for supportive infrastructure to help community members understand the thinking behind and the activities associated with the process. So let's start with some background like we normally do and get everybody up to the same level of knowledge about the project. Um, So the project location, the Webequie First Nation is located about 250 kilometers, if we can change to the next slide, please. 250 kilometers south of Hudson Bay and west of James Bay. And it's a remote community in northwestern Ontario. The purpose of the Webequie Supply Road is to move materials, supplies, and people from the Webequie Airport to the McFalds Lake area, which is in what's called the Ring of Fire region. It's also to provide employment and economic development opportunities to Webequie while allowing them to preserve and enhance their language and culture. And then finally, another main purpose of the Webequie Supply Road is to provide experience and training opportunities for youth to help encourage the pursuit of additional skills through post-secondary education. So, as I've mentioned before, it's not just a road. So there's more to it than that, and I'll get into that a little bit later on. But just to give you an idea of a bit of a description of the project, the road is planned to extend from Webequie Airport east and then south and then east again to the McFalds Lake area with a total distance of 107 kilometers. Of those 107 kilometers, 17 sit within the Webequie First Nation reserve lands. And we have a preferred corridor identified for the project. What that means is a 2 kilometer wide area within which the road would be situated depending on lots of different factors, but that gives us some room within which to specifically identify where to route the road. And then the actual final corridor width will be 35 meters. So 35-meter right of way for the 2-lane gravel surface road. Continuing on with the project description, there's going to be 3 major water body crossings. The first, leaving from Webequie, is from the island across Winnisk Lake, and that is about 200 to 250 meters. The second is to the south of that location across Winniskis Channel. It's about 30 to 40 meters span there. And then the final water body crossing is at the extreme major water body crossing is of the Muckatai River at the extreme east end of the project, near the end of the road, and that's again 30 to 40 meters wide. So as I mentioned before, the Webequie Supply Road is more than just a 2-lane gravel road. It includes both temporary and permanent aggregate pit or rock quarry areas that would have equipment for processing, meaning crushing rock, and of course, we need access roads to these areas. So access roads would have to be built from the main road to these areas so that they can be used to both build and maintain the road as well. Construction camps that would be temporary, accommodate construction crews, and then and in the cases of operations and maintenance offices, which would be permanent. Um, Both would include supportive facilities such as a small wastewater treatment plant and potable or drinking water storage. And typically associated with these camps are storage and laydown areas, which would be temporary, and they're used for storage of both equipment and materials. So let's move now to talk a bit about the alternatives assessment process. And I've gone over this before, but I think it's always good to refresh ourselves in terms of the wording that's used. So for every undertaking, when we say undertaking, we're talking about our project, for example. A quote, reasonable range of alternatives must be considered during an environmental assessment. And then these alternatives include both alternatives to and alternative methods. When we talk about alternatives to the proposed undertaking, these are what you call functionally different ways of approaching and dealing with a problem or opportunity. When we talk about alternative methods of carrying out the proposed undertaking or project, these are different ways of doing the same activity. So let me give you a couple of examples just to help you better understand this. So when we talk about alternatives too, and you can see on the screen now, we're talking about, again, functionally different ways of approaching and dealing with a problem or opportunity. So in the case of an all-season road, it could be using other modes of transport. It could be a cargo hovercraft, a cargo balloon or airship. It could involve upgrading an existing trail to a seasonal winter road if it existed, which it doesn't. It could be managing traffic demand so as to not need a additional form of transportation or additional transportation route, or doing nothing, just keeping things the same, the status quo. So that's what we talk about when we talk about alternatives too. So now let's talk a little bit about alternative methods. And you remember when I talked about alternative methods of carrying out a proposed undertaking, these are different ways of doing the same activity. In the case of an all-season road, this could be different routes. And in our case, Webquay Supply Road, we have three different alternative routes: alternative route 1, 2, and 3. So let's move now to talk about the evaluation of alternatives for supportive infrastructure. So as I mentioned before, when we talk about supportive infrastructure, there's quite a bit involved. There's quite a bit of different components associated with the road that are considered supportive infrastructure. So these include aggregate or rock source areas. They include construction camps and or laydown or storage areas. Access roads. I talked a bit about access roads either as well earlier. And access roads, I mean, they're not typically pits and quarries are not typically right beside where the road ends up being. Typically, there's an access road to get there. Some of these can be quite long to get to those deposit areas where the rock and the aggregate are located. When we're talking about supportive infrastructure, we're talking about types of structures as well, bridges or culverts that might be considered at the water crossings. And we're also talking about road engineering design as well. So when we evaluate alternatives for supporting infrastructure, just like we do for the road, we apply criteria and indicators. And so proposed criteria and indicators include when we're talking about supportive infrastructure. For example, when we're looking at aggregate and rock sources, we could be looking at the volume, so the size of the deposit, how much rock or aggregate is available at each location. but also the quality of the rock or aggregate. Is the aggregate, for example, of suitable size to be used for road construction? These are the kinds of things that we would consider, the criteria that are considered. And then other thing we talked about, access roads. Um, how long are these access roads? The length of the access roads is important. How many water crossings is important as well too. Ideally, we want short access roads so they would have a limited environmental footprint, and they would cross fewer water crossings as well. So these are the kinds of criteria and indicators that are used in the evaluation of alternatives for supporting infrastructure. So when we talk now about alternative aggregate source areas, pits and quarries, um, there are 12 locations that were identified as potential aggregate or rock source areas. Um, And in terms of aggregate and rock needs, just so that our listeners and viewers can understand, for construction of the road, a total of 2.8 million cubic meters of material, which includes fill or earth, gravel, and rock, would be required for the road, for construction of the road, based on our estimates. So what does that mean, like in real numbers? Well, for example, when we're talking about gravel, for the road base. So almost 1.3 million cubic meters of gravel would be required. So that's almost 130,000 dump trucks of gravel would be required to build this road, this 107-kilometer road. And then 1,500 cubic meters of rock would be needed. Typically, that would be needed around the culverts, the open culvert openings to prevent them from eroding. And then, of course, earth, over 1.5 million cubic meters, or 155,100 dump trucks of fill or earth would be needed to help form the road base as well. Now, for operation and maintenance of the road, when it comes to gravel, 2 million cubic meters of gravel is estimated to be needed to repair and maintain the road over an assumed 75-year time frame, and 5,000 cubic meters of rock. So let's move now to talk a little bit about construction camps. And construction camps are similar to the road project as a whole. There's more to them. And excuse me, these would include accommodations, or like a bunkhouse for workers, construction offices, a kitchen and dining hall, first aid station, communications system, wastewater treatment system, groundwater water supply well, waste handling and storage facility area, electricity supply from diesel generators, because there are no transmission lines, there's no power available in the area. Above ground fuel storage tanks and refueling area, and lay down and storage areas for equipment and materials. So these construction camps are fairly large places. There's a lot going on at them. There's a lot of facilities there, as you can tell, based on the list I just read. So we are estimating, based on the preliminary design, that 4 construction camps would be required along the length of the road. One near Webequie, and then another one in the north-south section between Webequie and where it turns, the road turns east. And then, so there would be 2 in sort of the west-east section of the road. In terms of water crossings, the Webequie Supply Road will require 25 watercourse crossings and 1 lake crossing. That lake crossing I talked about earlier is of Winnisk Lake. So bridges are proposed over 5 large water bodies or water courses, and culverts are proposed at 21 smaller water bodies. So when we select the type and size of structures for water crossings, there's a number of factors that are considered, including constructability and remoteness of the location. So constructability, what does that mean? How easy it is, how buildable something is. Um, and then when you look at the remoteness of the location, you want to try to simplify the construction as much as possible to have, and so typically what you would have is more prefabricated or already made pieces, and then ship them up there, and then basically assemble them on site. Um, Another consideration is maintenance and life cycle of the type of structure. We look at hydrology or surface water flow. Um, and then, of course, physical and biological characteristics at the actual water crossing locations, soil types, how wide the water body is, so the span of the crossing, any fish or fish habitat sensitivity, and then finally, and not certainly not the least important, is navigation of waterways by boats. Are boats using that water course? Is it a navigable water course? Many of these water courses in this area are used by community members to to travel to other areas. They connect lakes together, and in a very intricate network of water, especially in the Webequie area. So that's an important factor, is navigable, or can these watercourses be used by boats? So let's talk now about bridge water crossings. Um, Again, the type of bridge. There were 5 water crossings where bridges were recommended, and the style of bridge to use, based on what our preliminary design people have recommended, is what's called a composite steel concrete bridge, which it consists of a concrete deck supported by steel girders that run along the deck, and then those girders are supported by bridge piers. And then at the ends of the bridge, there are abutments who sit on concrete foundations, and they serve as the ends of the bridge, and then if necessary, the piers, depending on how long the span is, that determines the number of piers. The piers are used to hold up the girders. So that's the typical composite steel concrete bridge design. Let's move now to talk about the culvert water crossings. And 3 types of culverts are proposed for the Webquay Supply Road. The first being the open bottom steel arch culvert, which is can be a very large culvert, which sits on, basically the sides of the culvert sit on concrete walls. And you can see that in the photo there too. They sit on a concrete wall as their foundation, but they're open bottom, so they leave the bottom. The bottom is a natural bottom, and which makes it different from a steel arch culvert, where it's not a natural bottom. It's basically a steel bottom as well too. So the open bottom ones are used typically in situations where you've got maybe sensitive fish habitat, or it's important to make sure um, that you know the, just due to the environmental sensitivity of the area, whether it's aquatic plants or riparian vegetation near the water course, um, that the open bottom is used to to leave less of a footprint, I guess. An environmental footprint is the best way to describe it. And then finally, we have the corrugated steel pipe, which is exactly what it says it is, a steel pipe that's filled over top and allows the water to move from one side to the other. Let's move now near the end of our presentation and talk about the road cross section design. The cross section for the road, um, in general terms, you can see the cross section here. 2 lanes, each 3.5 meters in width. plus 2 shoulders, each each of 2 meters width for each lane. So the total is 11 meters. And then there's some rounding of the shoulders so that there's a more gentle slope from the shoulder down to the ground level, the natural ground level, the grade. And so that's the basic road cross section design. And then in terms of the foundation design, there are two different designs basically depending on where the road would be going through. So in the upland area, which is typically the area from Webequay until the road turns basically due east, that's what we're calling the upland area, so slightly higher areas with less water around. Um, the road will be constructed differently with sort of an earth fill base layer and then a sub base of aggregate and then a top dressing, like a top surface of crushed stone. However, in the east-west area where you have the muskeg and in the what we call the lowland areas, um, it would actually sit on the undisturbed peat, the road. There would be a geotextile, like a plastic mat that would be used to help reinforce the road and then transfer the load over a broader, a wider area to prevent road failures, and also to allow the road to sort of behave more as one unit, and so that you don't get certain areas where there's a significant amount of failure. And then on top of that geotextile, that plastic mat, you would have a sub-base layer of aggregate, and then of course the crushed stone on top of that. So that's the basic road foundation design. We're going to get into that in a little bit more detail in future presentations. But I just thought I'd give you a bit of a preview as to how that's going to work. So um, foundation design, the west half of the road has fair to good soil conditions. That's why we call that the upland area. And then the design is a little bit more simpler. And then the road in the lowland area is designed as sort of a floating road, as we call it, with that sits on top of the existing peat. And then the equilibrium builds up between the weight of the road and the strength of the peat. We use a geotextile fabric or a geogrid layer on top to, again, to distribute the load, the weight on the road more evenly. So that's basically how the road foundation is going to be designed. So we will now move to the next slide. And the next slide is we want to hear from you. And we encourage you to go to supplyroad.ca. There's a lot of information on the project there. There's information on how to contact us as well that you just saw on your screen earlier. And so we encourage you to go there. Look at all the material. There's lots of videos there, tons of videos. If you still have any questions, we would by all means love to hear from you. We would love to visit your community in person or and meet with you in whatever way is most convenient for you. We encourage that. We welcome that. And again, we'll be back again in 2 weeks to talk to you again about another topic. And that wraps up today's discussion of the alternatives for supportive infrastructure. We hope this was helpful, and we hope it encourages you to join us again in 2 weeks. Again, don't forget to keep in touch with our project team members via the contact information available on our website, supplyroad.ca. Miigwech, and we will talk to you again in 2 weeks when we talk about the proposed criteria and indicators for the evaluation of alternatives for supporting supportive infrastructure. Miigwech, and see you in 2 weeks.